Some time ago at Makerspace I go to, there was a little debate that popped up about a laser cutter that was on the network. And it had an IP address of 10.0.0.175. I don't actually remember what it was. I'm just using this as an example. And somebody wanted to control the laser cutter over the network, which is fine. We do that. And their laptop from the DHCP server got an address of 10.0.1.154. And they were having problems connecting to it. And some people said, hey, this is not on the same network as this. That must be why. Well, is that right? Well, let's take a look at how IP actually says this, because you don't actually know that from the information here. It's not enough to know that. So the first thing you should do in these situations is break it down into binary. So this dotted quad formation format is just for humans inputting numbers. What IPs really are 32-bit numbers. So if you convert two of the 32-bit numbers, it's much easier to deal with them when you're manipulating them like this. Don't try to do it in this. You'll just get confused. Convert it to binary and then convert it back as your final step. So here we have the binary representation of the same address. And likewise, we can do the same over here. Now, how do we figure out if these are actually on the same IP network? Well, what we do is we take the netmask, and the network in question had a netmask of /16. Another way of saying that is 255.255.0.0. And the reason that number comes up is because you're filling the first 16 digits with all ones. So we just go along from the most significant bit, 1, 1, 1, 1, 1, all the way down until we get 16 of them, and then we fill in the rest with zeros. Then we take the client's IP number, and we do a bitwise AND against that number. So in this case, when we convert it back, we get 10.0.0.0, and that is the network number. As far as IP is concerned, everything on the same network number can communicate with each other. Now, of course, if you don't have wires connected or something like that, it's still not going to work. But as far as IP is concerned, this means that you can connect without a router being in between the two clients. And likewise, we can do the same over here. So we fill in the 16 ones and the rest zeros, and then we do the bitwise AND operation, and we likewise get 10.0.0.0, which is the same over here. So these two can indeed communicate as far as IP is concerned. Now, the one thing is, this laser cutter, kind of a cheap controller on that. I'm wondering if the original programmers maybe didn't do it right and considered that this did indeed mean that it was on different networks. So the original programmers made the same mistake that some people were who knew a little bit about IP but not enough. And so they assumed it was different networks and just ignored the packet, and that's why it didn't work. So that can come up in the real world. Even if it's not following standards, well, it still doesn't work. You got to deal with that somehow. So anyway, this is a good approach, is make sure to go down to an actual 32-bit number rather than trying to manipulate this in subnetting, because it's not going to work if you try dotted quads. That's a really big piece of advice that helped me kind of figure this out. So I hope this helps. Have a good day.